In this session, he is going to deal about structural assessment and retrographic of seismic affected structures. I hope this session is more interesting. So I request the participant to utilize the session for enhance your knowledge. Now I call upon Dr. MP Muthuraj sir for their presentation. Thank you.
Thank you, sir. Good afternoon, all of you. Am I audible?
Audible, sir.
Okay. Good afternoon. So, in today's session, that we are going to understand how the retrofitting of the seismic affected buildings can be done. So that's what our aim. So before that, what I am going to do that just in my first presentation, I'll be explaining you how earthquake can be understood. So it's very, very important for one has to understand what is earthquake is all about. Unless otherwise, if we don't know about what is earthquake engineering, it's very difficult for us to follow some of the case studies that I'm going to tell you later. So first, let us try to understand that what exactly the structural engineering is all about. Earthquake engineering is all about. So for earthquake engineering, a bit of basic of structural dynamic is always very, very important. For any structural dynamic analysis, this is very, very important. A spring mass damper system. That's what we have to call it as. Mu double dot plus Cu dot plus K into U is equal to F of T. So I can explain you everything. There is M. M is nothing but mass. K is nothing but stiffness. C is nothing but damping. So here you see that when damping is absence, okay, when damping is absence, the type of study or the type of analysis is known as undamped vibration. So you can see that undamped vibration, which will be a simple formula, mu double dot plus K into U is equal to F of T. So here the force is a function of time. So the function of time always will be present because force is a function of time. So what is the time that we have to understand? Now later on we'll try to understand what is the earthquake force is all about, what is the time of the earthquake and all those things. Now let us try to understand the basics of the dynamics. So here you can see that this is what the standard form of the equation, mx double dot plus kx is equal to f of t. So for this, you can assume f of t as 0. When you are assuming f of t as 0, it is called as free vibration, which means that vibration without effect of force. When the vibration which is happening without effect of force, it is called as free vibration. When the vibration which is happening with the effect of force, it is called as forced vibration. So for that, first normally we will be finding the natural frequency. What is the real meaning of the natural frequency? Let's try to understand. Because we know that for static structural analysis, for any static structural analysis, it's always very, very important for us to understand that the spring constant or stiffness is very, very important, because you know that stiffness here is K. The stiffness is inherent property of the structure, because you know that stiffness is unaltered by the external forces. Stiffness is inherent property. Stiffness, because you know that when a beam which is subjected to a central concentrated load, what is stiffness? Stiffness, all we know that the stiffness is nothing but stiffness is defined as unit load required to produce unit deformation. So how much load required to produce unit deformation is nothing but stiffness. So stiffness is the inherent property of the static objects. Static objects in the sense f of t will not be present. Force will not be a function of time. Force will be a simple force, that's all. Force is equal to mass into acceleration due to gravity. So